When it comes to the NgRx SignalStore, then we have to say the basic functionality that it provides, it's pretty good. It gives us a solid guideline on how we can do proper state management in modern Angular. But for me, the reason why I went with the SignalStore in the first place was the extensibility which it provides. So the possibility to write my own extensions. And in this video, I kind of want to share everything I know about it. This video is quite long. You don't have to watch everything at once. So it's divided up into multiple chapters. And this video is also not made for beginners, or it's not an introduction video into the SignalStore. So you should already be familiar with the basic features like SignalStore, the function SignalStore, with methods, with computed with state. So let me quickly give you an overview of all the chapters. We will first start with an application walkthrough, where I am going to show you what our holiday store or SignalStore is all about and what kind of requirements, what features it has. And then I would say the first half is designed for application developers, and it covers the basics of the extensions. So we'll start with a normal extension. Then we will have an extension with parameters. We will have an extension with input constraints and also how we can use the withFeature. And at the end, we also have a theoretical discussion why you cannot just use a simple service when you want to have the same level of extensibility that the SignalStore provides you. The second part is then more for, I would say, advanced users. So if you are, for example, an application developer where you need to provide features for quite a huge application, or you are a library developer, or you're just interested, you want to learn more, then this is definitely for you. We will start first of all with a so-called deep dive, where we will see what the SignalStore feature actually is, and if it is possible that we can write our own extensions without using one of the predefined functions. Then we will have certain patterns where we can see how we can split up a single SignalStore into multiple files, where we would talk about very specific extensions. Then we have the dynamic extensions, where the callers or the consumer of the features should be able to define the name of the properties, of the state, or of the methods. And at the end, we also then have the non-polluting features, which I find quite interesting. So who am I? My name is Rainer Hanekamp. I am an Angular GDE, and I'm also a member of the NgRx team. And as such, we are also providing workshops on a regular basis. But for now, let's start with the actual content and with the application walkthrough. So let's first start with application walkthrough. Let's take a look at all the features which our SignalStore supports. So we start here with our holidays. This is the main feature. So this is this application which I use in most of my videos. And you see here, we are showing just holiday cards. What is also important is that each holiday card contains here this heart icon. This is already a separate feature, which means I can mark here a certain holiday as a favorite. Then we have here a filtering feature, which is done in the browser itself. So I'm not going back to the backend and request some new data. And as you see, I have here an input field and checkboxes where I can filter the holidays. Then we have here save for offline. This is the local storage synchronization. And we have here last updated, which means it gives us some kind of information when was the last time that the state was obviously updated. So in the end, we can say we have 1, 2, 3, 4, 5 different features. The main features are, of course, the loading. And all of that is now done in the SignalStore. So let's take a look at it. That's the SignalStore. And let's start with the main feature, with the holidays. So holidays is what we see right here. We are storing it inside an array. We have also some kind of status information with is loaded. And in order to load it, there is just a simple method, which is also called load. So it's a simple asynchronous method. We are patching the state, putting the holidays into it, and are saying from now on, it's loaded. The reason why I didn't use a resource is, in this case, it is for educational purposes. Resources in a real application, I would probably use a resource here for that. But I also have to say one important thing. I don't think that you can use a resource for everything, for every different fetching loading scenario. I think especially with the SignalStore, we will see that we will have certain very complicated fetching logic where the resource is not enough. So if you, in your case, if you say you want to use the resource, but for some reason it doesn't really match, then just don't use it and implement the loading on your own. The next thing are the favorites. So the favorites, they are also part here of the state. So favorite IDs, and as you see also for the holidays, that is a private property. So I don't want that from the outside somebody can access those state properties, so to say. For the favorites, I think the logic is obvious. If I scroll down, we have here an add favorite, we have a remove favorite, where we're just patching the state, and that's it. The next part is then also the filter, which is what we have here. So this is the filter with the query and with the type. And we also have just one, again, method, which is called search, but it has something very special, which is the skip same values, as you see here. This skip same values, maybe I just mention quickly what it does. It says, look, if query and type would have the same values which we already have in our SignalStore, then because I'm creating here actually a new object reference, the complete or the filter state would be updated. Because I don't want this, I only want to update it when the values of query or type are changing. The skip same values function takes care of that. So if query and type would be exactly the same values, not the object reference, then skip same values would return an empty object, and patch state wouldn't really patch the filter. This is what I want. And favorites and the filter, they are together combined with the holidays in order to show or to give the component the information about the holidays. And this is done in computed. So this is what we see right here. We are accessing the filter values. We are doing obviously the filtering by iterating over all the holidays we have. As you remember, I said we are doing the filtering on the client side. And then we also have here the map where I'm adding an information to the holiday if it is a favorite or not. So in this case, we can say we didn't take the original holidays because we need to filter them, but also additionally, we also have this need to add an additional property which does not exist on the original entity. And this is the one which is public. And then we have two features left, the last updated and the sync to local storage one. So we see here on hooks that we are loading from storage, which means we are going to the local storage. We verify if something is there. And if this is successful, so if local storage has certain values, then the isLoaded would probably set to true. And this is why we are only loading if the local storage is more or less empty. So the load from storage is also right here. We obviously also have a sync to storage to write back as well. I would say nothing fancy there. And then we have the last feature, which is the last updated from. That one might require a little bit more explanation, because you see here I'm using an effect. And I'm using an effect where I'm tracking the favorite IDs, I'm tracking the holidays and the filter. And these three signals, they are for me the criterion where I say if they are being changed, then I need to update the last updated from. So then for me, the state was changed. And this is why I have used this within an effect. Of course, I could have also gone with a Rx method or signal method. That would have also worked. But in my opinion, I decided not to do it because I just don't want to create a separate method just to track three different signals. It's not worth it. And in the end, we then also have here a timer which runs every second and starts immediately. And what the timer is doing is that it calculates, or that it just processes or gets the pretty name for the time. So what do I mean by this? If you remember, the last update always shows a text, which is what we see right here. And the text that you see here, this is the one which this timer is more or less calculating. So it's a pretty timer function. Not so important how the implementation looks like, but I decided in this case that I don't want to expose the last updated with a timestamp to the component, but I want to really remove as much as logic as I can from the components, which means the components just gets the text that it needs to show, and that's it. And this is what this timer here is also doing. I couldn't use a computed for this because obviously it needs to run every second. It also has an impact for the change detection, so it also tells the component to update the DOM. And this is why the last updated name is actually a real state and is not part of the computed. So with the SignalStore extensions, or with the extensibility, you can say there is a certain feature in your SignalStore where you think that one could be a good idea to use it also in a different SignalStore. So you want to kind of extract it, make it very generic, and then also use it in different stores. And in our case, we kind of can say there are 3 different features. The first one is the last updated. The second one is the local storage synchronization, obviously. And the third one is the possibility to add favorites. And the way how we do it is obviously we have to go back into our VS Code. And first of all, I need to think if I want to start with the favorites, because that's the easiest one. What do I actually need to do? What are the key members of that favorite feature? And that's very easy because it's first of all the favorite IDs as a property of the state. And then second, it's the 2 methods which we have, the add favorite and the remove favorite. So these 3 members, so to say, form the favorite feature for me. So what I'm doing right now is that I will need to find a place where I can put the favorite feature. I have already created here a directory which is called SignalStore features. Makes sense. And I create a new file and I call it withFavorites, TS. Because in the best case, I have just one function which is called withFavorites that I can use right here. And then I can remove the add, remove, and the favorite IDs from my holiday store. It's just a one-liner which replaces more than 10, and in the future even more lines of code. So I say I have a function which is called withFavorites, and that function now returns something which we call a SignalStore feature. You know, we don't return a sub-signal store, but we just say, well, this feature, these favorites are actually not meant to be used in an own signal store, but they should be integrated into one. That's why we can't use SignalStore, but SignalStore feature. The signature of the SignalStore feature looks almost exactly as the SignalStore. We can use with state, with methods, with computed, with hooks, whatever we want. So I would say we start with the state. So I have a state, which is called the favorite IDs. Again, it should be private. And it's an empty array, or as we have written it before, it's a new array of number. And then I also have to add my 2 methods, which I think is also straightforward. So I say here with methods, I'm getting the store. As I said, it's the same way how I would have done it in the SignalStore. And to make it a little bit quicker, I'm going to copy and paste the add favorite and put it right here. Also have to patch the state or import patch the state. And in the end, you see the store that we get here is aware of the favorite IDs. Of course, we have defined it before. And that's it for the withFavorites function so far for now. I can now also remove the property from the state with the favorite IDs, remove it. And now you will see, if I scroll down to my holidays computation, that here favorite IDs, of course, is not there. Obviously, I have just removed it. But if I say here, right in the place where I would usually do with methods, with computed, with state, I say here with favorites, and I just call it, that all of a sudden that error goes away and favorites IDs are there like they would have been there all the time. Yep. So if I go here, for example, to my state and ask it, we see here favorite IDs, but we also see the methods add favorite, but also remove favorite. And I don't even know, without looking, if this is something which I have defined directly in that file, or if it comes from a separate file. Maybe I want to use the with, I want to move the with favorites up to the top. Maybe here after the state. In the end, you have to put it before the first time you're going to use it, obviously. Maybe a different way of explaining what the SignalStore feature is doing, it's kind of an inlining function. So if you think about it, I could have also just taken with state and with methods, as it is right here, and replaced it with favorites with that one. So I would then have here another with state, that is of course possible, another with methods, and in the end, this is what I see here, where I would then go to the SignalStore feature, and I could say, look, this is now, this part is now the with favorites. This is what I'm extracting into that function. And it doesn't get any easier, because it's really like extracting one feature into a separate file. Good. So that's the easy way. That's the easy part. And now let's do the second feature. The next one will be the local storage synchronization. If you remember, it comes with the two methods, sync to storage and also load from storage. And also in our on hooks, in on init, we are loading it from the store initially. So how do I do it? In the same way as I have done it with the favorites. So I go here, create a new file. I say this is with local storage TS, can call it like this. I'm going to export again a function where I say this is with local storage. So I'm going to return a new SignalStore feature. And then I'm adding my methods. I say here we have here our methods, store. I'm going back and copy those two methods, put it right here. Good. Import the missing things. We see message service is a dependency that we need to use here as well. So I say, okay, then use here message service, inject message service. Oh, why is it not there? There it is. So far, almost good. The problem that we already have now is, of course, with the storage key. Because this is now something where I would say I, as a generic feature, I don't really know where, in which, what kind of variable, what kind of name should I use in the local storage. This is an information that my SignalStore needs to tell me. And the nice thing is that this is very easy. We don't need to reinvent something new, because the information flows from the SignalStore down. It calls with local storage. So in the end, I can say here we have a storage key. This is of type string, and I'm just using it right here. Like this. And if I want, I can then also say yes, and here's also name. For example, this is the holidays, or this is something else, where I say here this is the name is also something like a string. And then I can reuse this in my message service, where I say, okay, whatever is saved, I don't know the name of it, but I'm just then using it, whatever the SignalStore has told me. Let's go back. So we have here the holiday store. I can remove these two methods again. I can also remove the message service from with methods because I don't need it anymore. And I can even remove the complete properties because I don't have to store the props somewhere because no one in the SignalStore is accessing it. I'm just providing the name of the storage key one time when I call with local storage. So I say here you have your storage key. This is holidays. And by the way, the name that you're going to use is holidays. That's it. And if I scroll down to onInit, then we see that the store load from storage is still there. Of course it's there because it has just been inlined with the with methods. And since we're already customizing our local storage feature, so in the end, this is now meant to be used for different stores, of course, and it could not happen that one store says, I want to automatically load it from the local storage, but another store might say, no, I just want to provide a load button to the users and they should decide if they want it. Yeah, no problem. We can then also extract the loading logic into this feature. I just need to know, do you want to have an auto loading? Where I would say this is by default, it's true. And then I have here a with hooks where I say, okay, we're getting here our store on init. And again, this store is not the store that is using us, but this is this mini store, which does not really exist inside of the SignalStore feature. So we have here the onInit, and then I'm just asking if autoload, if that is true, then I go to my store and I say, please load it from the local storage. Now I can go back and I can also remove this part. And again, the holiday store has shrinked a little bit and I have a second feature now, which I can also use for other stores. Now comes the more advanced thing. Now we are also extracting the last updated feature. So in the end, last updated feature means we have in our onInit the interval, which updates it every second. And we also have this tracking mechanism where the last updated state that we have right here is kind of updated. It also, of course, means we have two state properties we also have to move. And this is last updated and the last updated name, obviously. Good. So let me close these things, scrolling down, and we are saying in the same way, we have a new file, which is called last updated TS. I'm creating a function with last updated. And as we know, it always starts with a SignalStore feature. We can also already move the state into it. So I would then say, okay, these two things, they are coming here. I mean, in the end, it's just simple copy pasting. And let's just give it a try naively and say we have here also our with hooks on init. Let's see what's going to happen. So the timer and the effect. Now, do I also have to copy this one? Where is this one coming from? No. It goes here. Have to import, of course, all the missing things. RxJS, the effect is not coming from sort. That's the one coming from Angular. Calc time is something which I can also move. Yes, because this is something which is only meant for last updated from. Good. So again, store has already shrinked again quite significantly. Yeah, and now the funny part is, what do we do with that? Because this is something where I would say the signals that this last updated should track is something which the SignalStore, the calling SignalStore, the consumer of this feature, should define. I don't know in which store I'm being used as the SignalStore feature, so I don't have any idea what kind of state property it has. We could now say, I want to do it in the same way as we have done it before with the local storage. It's just a parameter that needs to be passed to the function. I would say, because I don't know how many signals there are, and I just make it easy, I would say tracking signal, and if there are multiple signals that should be tracked, then they should just create a computed and call the computed and tracking signal. I don't care, I just want to have a signal in the end which is of type unknown, because I also don't care what kind of value it is, and then I just want to call tracking signal right here. Yeah. So far, so good. At least for the implementation of this feature, everything looks like it's working. But if we now go back and I say here, I want to use the with last updated and I call it, then of course I now have to provide those tracking signals. How do I do this? If I say this, there is no this, we are not in the class. If I say, do we have the access to use the store like we have done it in the with methods? No, that's also not available. So that's a little bit of a problem. And this is why, in this case, there are two approaches. The first one is that we are using something which I like to call the input constraints. So I can say as a SignalStore feature, if I'm being used, of course, I'm providing this and that, but I also want that the caller needs to fulfill a certain contract. It needs to have certain methods, it needs to have certain properties or a certain state. This is what I can define in the first parameter of the SignalStore feature. And the way how we do this is that we use here the type method from NgRx Signals. That's a generic function with a type. And in that type, I'm defining now what my calling SignalStore needs to fulfill. And since I said before, I only want to have a tracking signal and nothing else, I would say the calling store needs to have a property. So there is props, there is also state and methods. And the property needs, and this props needs to have one, which is called tracking signal, and that's a signal of unknown. And it should be private, of course, because I don't want to expose this to the outside. I can also remove this part, do it like this. Then I can go back into my SignalStore and you see it already starts to complain because it says this with last updated has a certain requirement that I cannot fulfill. And then we usually get a huge error message. But in the end, what is important is that it says here types parameters of store and store are not compatible with each other. And this always indicates that you probably are using a feature which has constraints that are not met. Yeah, but if it's a property with a tracking signal, then let's just create it. So I would then say here we have props. The props has access to the store. We have then here our tracking signal. Yeah, and then let's just add it. So I would then, as I said it before, I would then maybe just say I have here a certain computed. Could of course now also come up with a with computed that would also have worked here. And I then say, okay, I want to have the holidays, I want to have the filter, and I also want to have the favorite IDs. So these are the things that count when they are changing. This counts as the store has been updated. And I'm putting this right here. So I would then say here, look, you have holidays, you have a filter, and also you have a favorite IDs. I update it, comma. The with favorites goes away because it sees that this tracking signal is there. Let's maybe also make it a little bit better because we can also say it's actually with computed. Then this is a little bit shorter because the with computed adds the computed automatically. but we see that we still have a problem. And again, it says the types of the parameters are incompatible with each other. And the reason why it says it is because I did not install or activate ESLint, the ESLint plugin from NgRx, because that one would have told me, look, when you use those kind of input constraints, then it's highly recommended that you also just do that. No questions asked, just do it. That is necessary because of internal TypeScript limitations that we are hitting here, and this one would then be able to fix it. Something, by the way, I've just missed, maybe also add here this store tracking signal. And then I can go back, and if everything works, this looks good. So SignalStore, the error goes away. The favorite IDs are here not available. Yeah, of course they are not available because they are defined a little bit too late. We move with favorites up to the top. And as you see, the compiler was just telling us everything is all right. Yeah, so that's, I would say, quite a powerful feature. But as I said, there is also another approach. Because if we're talking about very generic features, then we don't want to have, we want to limit the coupling between them. So in the best case, as a with last updated, I don't want to depend on anything of my calling SignalStore. But in this case, I'm actually saying, no, whenever you want to use me, you need to provide here this tracking signal, which in this case is fine. But there could now be the case that I'm using a certain keyword or a certain property or a state, which could already exist, but for a different use case. For example, I could say the property, the name of the property that I've decided for is called selected. Now, chances are quite high that the calling SignalStore already has a selected property, which it is using for something completely different, could be a Boolean or something else, and then it just doesn't work. It could also be that maybe we have another very generic SignalStore feature, which for some reason also has a selected property, but again, it has a selected property with a different type because it uses it differently. And these two things would collide, and in the end, we have to decide for one because we can't use both. And this is why there is now also a decoupling feature available. Because in the best way, I would say I don't want to define anything, any constraint at all. You just please give me the tracking signal right here, as we already had it in the first version. So I would say, look, I have a tracking signal. It's a signal of unknown. I don't want to tell you anything what you need to do or what you have to provide. I also don't need this fix. And I can just then call here the tracking signal, and that's it. The SignalStore doesn't even have to create a property or something for me. It's just give me that tracking signal, please. And the way how we do this, or the way how we can do that, is that there is now a function, another function that we can wrap around the with last updated, and that one is called withFeature. And what withFeature brings in, so I need to import it, withFeature, like this. And withFeature now brings in the same functionality of like with methods or with computed. It gives me here access to the store, and it expects that I return another SignalStore feature. But because I have now access to the store, I can do what I've done here in computed as well. So I take it. So I say I want to have this with holidays filter in favorites, and I will then do here the computed on the fly. So I put it right here. Say this is computed, copy paste it like this. I can remove this one because I never need it for my internal usage, and I am done. So the compilation is also running perfectly fine. With last updated is also happy The only thing which we maybe could improve is that we say, well, in the end, it doesn't even have to be a signal. It just needs to be something which we call a computational function. So it is just a function which I can just call. And if within that function you are calling other signals, then all these signals will be tracked. Because as I said before, I'm not really interested in the value, what this tracking signal is returning. The effect takes care of the tracking. And it also makes it a little bit easier because I don't really have to do here a compute it anymore. I can remove it and it's just a function at the end of the day. And again, that's it. Yeah, so this withFeature, again, it's actually a very small function which can have a big impact because what I have now achieved is a full decoupling of the SignalStore and its feature which it is using. But again, it is a full decoupling, but still there are certain dependencies between them, but these are now simple parameters. And of course, we could now also extend the parameters. So I could then say here the interval has also a default value of 1000. Of course, then we also add here the interval like this. Yeah. So in case I want to change it at some point in time, I can then also update the interval. So let's quickly check, but I think we are now through. Yeah, removed everything. So the store has again significantly reduced in terms of size. Let's quickly go through. We have now 3 different features extracted. If we go back to our application, the last update, we see it's still running. If I reload the page, it says it's just now. The save for offline also works, as we see. And this one is also working. Wonderful. So there is now one further thing, which is more like a design discussion. If we look at the with favorites, that's the easy one. Then you see here that I have the add favorite and the remove favorite. So these are methods which are part of the holiday store, of course, immediately. The problem now is, it could not be that the store says, when I want to add a favorite, maybe I also need to do something else additionally. So in this case, the store would have to, for example, if the store says I need to call the endpoint to add a new favorite, then what the store would have to do is it can't just create its own add favorite where it then says, okay, and now I'm calling add favorite here with this ID number that will cause an overriding warning in our message. And maybe also let me quickly show you what I mean, what it has to do. So there is also an endpoint where I can add this ID. So I have this additional logic which I have. And then of course I have now a little bit of a problem because the with favorites just adds a public method which is called add favorite, which only has parts of the functionality that I want. And then I have to maybe come up with my own with a different name, like add my favorite or something else. And in the end, that's already a problem because who says that each component will then call add my favorite? I guess no component, because they will all call add favorite, which is the wrong one. Other use cases are also possible. For example, you want to add favorite automatically for another event. For example, if we say we have those holidays which we have, they can be added to a basket, like add to basket. And then I have here again a number. I would call the holiday client, would say put this into the basket, but by default, if a customer wants to buy it, then we can also automatically add it to the favorites as well. So I would then also have to call your store add favorite ID one, which would then do that stuff. And to avoid these things, there is something where you can use so-called predefined updater functions, which would make sense, especially in the use case for with favorites. So the idea is that the with favorites does not expose the add favorite and the remove favorite as methods, also not as private methods, but it provides so-called standalone updater functions. How do they look like? We will first of all have to define the type of the favorites state. So I would say our favorite state has this favorite IDs, which is a number array. And then I would say add favorite is a simple function like this. So you give me the ID of number. And again, I do now copy and paste. And what I would then do is that I'm not going to patch the state, also not the store, because here I'm a standalone function. I don't have access to these things. But what I can do is that I can return the favorite IDs. The problem now is, if I want to add a favorite, I need to have access to the state because I need to use the existing ones. And that's why we are just returning a function which says, yeah, the function will have a parameter that says you need to provide me an object literal, like a state, which is a favorite state, which fulfills this contract more or less. And then I can access here my favorite IDs if I want to. The problem now is, of course, we can then also change it here because that's an updater function. And now we have an add favorite function, and what we have done for that is something we can also do for the remove favorite. So maybe just copy it. Remove favorite. And I would then say in this case, we are filtering out the one which we don't want to have. So state favorite IDs, and that's the new one. Then we have the remove favorite. So we have now two standalone updater functions. Remove it from the methods, which means the withFavorites only provides the state. And now the calling SignalStore now needs to implement, of course, this add favorite or however it wants to call it. But this is the advantage because the SignalStore now has the chance to define in which process the add favorite should be executed. So I can say here, I have an add favorite. I also have my remove favorite. I have now the time to call an endpoint. I can now also do something else like showing a message dialog or whatever I want. Everything is available. And I only have to say here patch state. I'm providing here my store as it is. And instead of now directly going to favorite IDs, I just say add favorite, importing the function from this withFavorites file. Would be nice if I also would export it, of course. So like this, add favorite. Yeah. No, doesn't find it. And remove favorite. Good. So we have now here add favorite, and I say this is the ID that I want to add, and I'm done. The patch state is type safe. It knows or it checks that whatever add favorite returns also does exist. Which means if I would make here a mistake or a typo, and I would say my favorite state isn't just favorite IDs, but it also has foobar or something like this, then the SignalStore to the outside would now start to complain. Sorry, I put into the wrong one. I have to put it here to favorites state. And if I, of course, now go back, the patch state will start complaining and would say, no, this is not the state which I have. I'm not aware of this foobar of whatever you want to have. So in the end, the error happens when we use the add favorite in a patch state. So that's very type safe and very calm to know that although it looks like it's completely decoupled in terms of types, that the type check does still exist. Yeah, and of course I'm doing the same here also for my holiday client for the remove favorite. So I say here I want to remove it, and then also call patch state store remove favorite with ID. Good. For some reason Right, and now it works again. And it definitely makes sense because we still have here this nice thing that I, as the signal store, don't necessarily need to know all the time how the state is internally updated. If, for example, the favorite IDs, the state of it would contain more properties, where in the process of add favorite, I have to update more than just one, then I have here a function exposed by the author, so to say, of withFavorites. And my signal store, I can just call the function and it's doing the rest. In case you know, with entities, we will see that one also later. That one comes with a lot of those standalone functions, and they all kind of, so the entities plugin provides two different properties for the entity management, which always should be updated in synchronization with each other. And so that you don't have to implement the logic on your own. The updater functions of with entities do this already for you. It's the same concept here. Good. So that was quite a lot. I would say that's the basics. Let's do a quick recap. Then I want to say something general, and then we can already move on to the next part. So recap. We have 3 features. We have again the favorites, which we see right here. We have the last updated from, we have the save for offline. We have created 3 different functions for it, whereas the with favorite is probably the easiest one. We have a SignalStore feature function, which in the end is nothing than just inlining whatever comes here into the calling SignalStore. We have also seen with last updated, where we were using where we made use of the parameters, because in the end it's just a function call. So as the signal store, I can still define certain parameters which are then applied internally. And with the local storage, then also with the with last updated here, but this is something which I have already removed. There we have also seen that there is this possibility of an input constraint, where I can say the store which uses me needs to fulfill these and those requirements, but it comes with the price of a coupling, where the so-called withFeature function can make it a little bit easier. So here we have it, where we can say withFeature. So the with last updated from doesn't have the coupling anymore. Let me mark it like this. And then we can provide methods, properties, signals, or even compute it based on our state properties as a normal parameter to with last updated from, which means we have the maximum of decoupling available, which is something that I would recommend if you're really working on very generic features that you want to not just use in multiple signal stores in one application, but maybe also in for other applications, or maybe you even want to create a library and publish it for the public as an open source project, so to say. So as I said in the introduction, for me, the basic part of the signal store, which is about with methods, with states, with the deep signal, with the patch state functionality, which provides us this kind of immutable protection, that is all good. But still, for me, when I first saw it, it was not enough. But once I saw the power that you get with those extensions, and we are not done yet, there is still more to come, this was then for me the flipping point where I said, okay, this is really powerful, because whatever I want, I can now implement on my own extremely easily. And I still hear a lot of developers who are saying, yeah, SignalStore, it's good, but it's another liability, it's another third-party library which I have to install. I don't want that, because I just want to create a single service, a simple service, which contains the signal, which has methods and computers around it, and I don't need to use full state management. Where I would say, yes, I see the point, but you have not seen the extensions then so far, because this is the main selling point for the SignalStore. And given that most of us are working in larger applications where we will definitely have the need for multiple generic features, this is why you should use the SignalStore. If you're still not sold, in the next unit, in the next chapter, I'm going to try to implement that service on my own without the SignalStore, and then you will see how hard it would be, or almost how impossible it is, to create those kind of extensions in the same simple way as the SignalStore does it. So why do I have to use the SignalStore and cannot go with a simple service and reach, of course, the same amount of extensibility? Let's just say I've never seen the SignalStore before, and I have now the need to come up with the same extensions in my application. So I would maybe start with writing a service on my own. I would maybe call it Vacation Store. Yes, so I wouldn't say this is a simple class, Vacation Store. It would be, of course, injectable, in this case also provided in root, like this. And then, of course, I would manage my state internally. So I would have here a private, a read-only state where I say I have here my signal. We have here my holidays, so I would call them here now vacations. But it's a holiday array. And vacation, I would then say is loaded, is set to false. And I would have then, of course, also provide my public computed, where I will say I have my vacations, which is coming from a computed that accesses my state and says, here you have your vacations. And the same is then, of course, also true for the is loaded, like this. I would then continue maybe to come up with a certain logic, like a loading method, maybe also a computed, I don't know. But in the end, I will also have something which is then called update state, or let's just use patch state, where I say you give me some kind of value of your state. So let's just say unknown to make it easy, because that's probably not the hard part. Patch state logic. You will figure it out. And now we have the need for a favorite IDs that we want to add, and we want to make them generic. Since we have classes, we will very likely follow with class inheritance. So I would say, okay, I have another class, which is the favorite store. It also has, again, this time it will be protected, because I want that my vacation store is able to access it. And I would say I have my state with signal, and I would say, yeah, we have here my favorite IDs, and that's a number array as well. In order to make sure that the favorite ID store cannot be instantiated, I could also make it an abstract class, like this. And of course, I need to go then to my vacation store and say, I want to extend now the favorite store. So now I already have my first issues, as you see, because the favorite store also has a state. I also have a state. Each store brings its own state. How can we fix it? Well, we could in some way, we could say, look, I as a favorite store, I will provide you with a constructor. You give me some kind of state, which is an object, and I'm going to update my state with it. So I say here update value like this, and then also spread here the new state. Let's call it the new state, or the, like this. New state. And this one goes maybe here. Now as a vacation store, I would have now my constructor where I say super, everything is super. and I am going to copy this one here and then hope for the best. Of course, here we would have a few problems with the typing, but I would then say here again what I said in patch state. This is something you can figure it out. Good, but now let's say we also have something else. We have not just the favorite state, we also have our local storage state, because this is another feature we also want to have. So I would then say here abstract class local storage store, and as we know, we have a save method and we have a load method. Load from local storage, save to local storage, something. And now we have a problem, because what do we do now with the local storage? I can't just say I'm going to extend it like this. There is no multiple inheritance. It's always for one superclass. So in the end, what I would have to do in this case is that my local storage maybe is going to extend the favorite store. And then of course I need to extend the local storage, and then I'm inheriting of course all the save and loading method. But here's the problem. Maybe I just wanted to have the local storage store or the save and load, and I didn't want to have the favorite IDs. Then there's just no way out. I will always inherit the features of my favorite IDs, of my favorite store. And if you now think about it, if you say you have a decent size of your application, and maybe you have 5, 6, 7 different classes like this, then you will end up in a huge class with a lot of methods, with a lot of properties. You will also pay a price probably in terms of bundle size, of course. And it is something which I definitely don't want to work with, because I always get everything even if I don't need it. So you might have just one tiny signal, you just want to use the load and the save, but you're still getting all that stuff from all the other classes where you also have to inherit from. And of course, we can't blame Angular for that. These are just the rules how object-oriented programming works in JavaScript. And this is exactly what the SignalStore tries to fix. It says, well, we can't have multiple inheritance, but in some way we want it. We want to selectively define those classes we want to extend. And since this doesn't work, we have to find another way. And that's also the reason why the SignalStore, if you ever asked yourself, works mainly with functions. Because each function that you see here, be it with favorites, be it with local storage, be it even with state, all these functions, you need to see them as their own classes, which we can add whenever we want them, but never all of them at once. In the end, internally, everything comes together in a class, so it will be a class as the end result, it will be a service, but we have this nice way of scaling now the amount of features. I can have 10, 20 different features. It doesn't hurt me because each SignalStore only contains those features that it really needs. In the next chapter, we will take a deep dive, a deep look in how those kind of SignalStore features are actually implemented internally, not implemented, but what they're actually doing. Because there might be certain edge cases where you can't use the SignalStore feature, then you have to go one level deeper. In its core, the SignalStore is a dynamic class builder. So it says I can create you dynamically a new class, and you just need to give me the properties and the methods. And because it's state management, there is then also a third slot, which is then of course also reserved for the state itself. On top of it, there is a lot of TypeScript type code, which also gets removed when the whole thing is compiled into JavaScript. And in the end, we could also write our own functions without using a SignalStore feature. The way how the SignalStore and the features are communicating Works like this, that the Signal Store presents something which is called the inner store that has slots. There is, for example, a slot for the properties. There is also a slot for the methods and some other stuff. And each feature can then just add its things to these slots. And in the end, everything is then just merged together and we are getting one class out. I said before, we can write our own functions, but we usually should not do that because this requires advanced TypeScript, as we will see in a minute. So in the end, you can also say all these with computed with methods, they are utility, they are convenience functions, that it's extremely easy for us to add new features. There is one exception to the rule though. We cannot access the state slot, so to say. So we are not allowed to access the inner signal which contains the state. This is only allowed to the functions which are part of the Signal Store, for example, like with state. Yeah, but if we, for example, want to say now, we want to create a new feature, let's say it's called withUser, where we add a user object and then maybe also a method. And we don't want to do this with Signal Store feature, with methods, with props, then we can do it. So I'm going to create now a new function, which I call withUser_ts. I say export function with user. And since I'm not going to use the Signal Store feature, I now have to define the type that I'm going to return. So I would say here, I'm going to return a Signal Store feature. Yeah. So the type that the Signal Store feature returns is what we see right here. The Signal Store feature says, you need to give me the type that you're getting in because you get access to the store, but you also need to tell me the type that you are returning. So the things that I, as a withUser feature, now start to add to my store. So we usually have an input and we also have an output. And since we don't really know what the input is, we are just using it here as a generic type because the input will be provided by the Signal Store when it calls withUser. But what we can do is that we can say we are actually the input is a constraint or has a constraint that it needs to be a Signal Store feature result. And this is what the input is. That's the first type of the Signal Store feature. So again, remember, this is what goes in. And what goes out is now, of course, again, the input, but we are defining now here the type, which contains all the things that we are adding to the store. And we usually have here an empty feature result. So it's also a Signal Store feature result, but that's empty, which means all the slots which are necessary do already exist with this type. And then if we take here a look at this type, we see that it says you have a state, you have props, and you have methods. So these are the three slots where you could now start to add things. And I say I need to add one property, because if you remember, I said I can't just add something to the state, which is the user object. This is what I want to add to props. And I also want to provide a method where the user can set a name or something like this. So I say I have then another type where we have props. The props contains now a user object with a first name of string and also a last name of string. Good. And next to the props, we also have methods where I say, yes, set user. And I say, give me a name of type string, and then I will do something. So kind of then returns void. I save it, and this is now the signature that this function has. And now TypeScript tries to help us because we already say we are returning a Signal Store feature. And the Signal Store feature is a function which is getting the store. It's getting this inner store that I've mentioned before. So we have here a property. I don't have to define the type for it because the type is implicitly already included in this Signal Store feature type itself, the type of this parameter. What is important though is that I'm returning the store. And we usually also make this immutable. So we are creating a new store object, which means I'm going to use here the spread operator, where I say this here is the store. And there is something obviously missing. Let me quickly check. So user is declared here. Yeah, of course, now TypeScript starts to complain and says, yeah, but you're returning a store which is missing the user object and also this method that you have defined. So that was actually something which we could expect. Yeah, so what do? We would have to create here a function out of it, like I have to add here in my braces. And I would now say, when I'm returning here this store, I want to have a user object. This is the one that I want to add to my properties, because I define it like here like this. And I would now say I have a first name, which is empty. I have a last name, which is also empty. And this is what I want to add now to the props, because the store, again, don't we see the type here? No, here we see it. It's an inner SignalStore. Maybe let's do it like this. Here we see it better. It has methods, props, but it also has the hooks and the state signals. These things, they are not included in the feature result because hooks, of course, is something which we can't actually access when we have to store. Hooks are handled internally. Good. Yeah, and then I just say, okay, I want to add here my new props. And I have to be careful because I also, of course, have to include the other props which have already been defined before. So I would then stay here another spread operator where I say, and these are the props. And then with the methods, I'm doing exactly the same. So I'm adding then here the methods property where I immediately do the spread operator of the existing methods so that they are not gone. And then I say I have a set user method. In this case, it's a function where I'm getting the name. And now please apologize string. And now please apologize the hackish approach, but I would say first name, last name, and we just hope for the best, namely that the name contains at least one space. And this is what I would then add to my user object. So I would then say here you have your first name and then user last name. Here's your last name, like this. And that's it. So again, in the end, there are a few things we have to remember. This SignalStore feature, the whole type that we see here. So we have to implement, first of all, on a type level, what things we are adding to these slots. In this case, I say I only add props and methods. And we also have to make sure that in the implementation, we are returning the store as we have received it. But on top of it, we are then just adding our own things. So there is one implementation part, which is now with the red rectangle. And then there is also the type part, which of course needs to fit together. And this is exactly the reason why we should not do this, because in the end, it is much easier to do if we have a SignalStore feature function where we can then very elegantly say, well, with props, with methods, we can even use with state if we want to, and we really don't have to care about SignalStore feature results. It just works. But just to prove that this is the correct, that this is also just a pure SignalStore feature, let me go to the holiday store, like this. And let's just say here with user. So I'm just calling it like any other. And in my store, if I now open it, then we see that there is actually a property of user. Careful, this is not state, this is just a property. And we also have the set user function. So if I say here set user, let's use my name, self-promotion, and I would then show first and last name in the template. I have to go to my holidays page. where I would say here, I have a p tag. And then I can say here, holiday store user first name. Again, it's a property, so I don't have to call it. User last name like this. And then let's check out if it's actually working. Yep, it says here, my name. Of course, as I said before, if you would have now the desire to do something like this, maybe just for learning purposes, but you also want to put the user into the state, how does this work? As I told you before, we can't access the state here in the store because that's a hidden symbol. But what we can do is that we can use then the with state. We can also integrate the with state here in this as well. Because the with state in the end has the same signature as with user. So it's in the end also a function which gets the current store and then updates a new store or returns a new store. Which means I have here the incoming store. So I could theoretically say with state. Of course, I call it like this, where I say, well, I have a first name which is empty. I also have a last name which is also empty. Of course, I also can then return this part here. And I can say when it comes here to the state, I will have a user, or maybe I can just rewrite it like this. Just say this is not a state slot. So you see from a TypeScript, from a type level, I can actually define the state, but not on an implementation, in the implementation part. And well, with state returns me this function, which contains the store. So in the end, if this is a function, what with state is returning, then I can call it. And you see it says, give me the store. Then I say, okay, here you have it. And that one returns an updated store, which contains the state. Yeah. So I would then say here, const updated store, like this. Can remove this part. I don't need to add the properties anymore. The updated store needs to change here. Needs to change here as well. Well, and how do we update state? Not by directly accessing it, but via patch state. So I go with my patch state, I go to the store, say I want to update now the user first name, last name. You see from a TypeScript level, TypeScript now says, no, the store does not have a user. I don't even know what it has, but it doesn't have a user. It's not a type safe, which is true because the store doesn't contain the state. The updated store contains the state. So if I say here updated store, then it should actually work. If I make it correct, if I make it the right way, good. And I have now created a self-written SignalStore feature where I'm reusing other SignalStore features like with state, for example. Let's check it out if it's actually also working in the holiday store. So I would go back to my holiday store. I would say set user can still stay, that should still stays. And maybe I want to print out, I want to have the username, the full username as a computed. So I would then say, okay, we have now username. And in the end, that means that I'm going to access my state. User, is it there? No, it's not there because I have to define it before. Here we have the user. It's the first name. And then I say again, state, user, last name, call it here as well, comma. And then we have a new signal. I can go back to my holidays page and there I can then shorten this and I say I want to see the username. I save it, I go back and we see it shows up again. Okay, so the question is now, will I ever or will you ever need this kind of approach here? Hopefully not, but of course there are always edge cases where you need it. One edge case could be where you say, well, you only need to do something on the methods only. And if you're dealing with the normal SignalStore feature, you can of course always say with methods, you want to do something on the methods, but then it's hard to differentiate what is now a method and what is now a property. But here with this approach, we do have access to this other store type where it explicitly differentiates between methods and properties. And what I could not do is that, for example, I want to have a certain feature, a profiling feature, where I say I want to add a proxy to each of the methods where I am measuring the amount of time it took to execute it, and then also, of course, print it out to my console. I have already prepared something for that. Let me quickly go back. Where do we have it? This is the add profiler proxy. And as you see here, it's just a simple function. It's not so important what it does, but it says add profiler proxy. It is expecting a function. So my method, it also wants to have the name. And then it just does some basic things. So it's starting here the profiler, where it says I'm going to measure the time from now until the end when the result was returned, and then I'm just printing out the information. And since I only want to apply these to the methods, this could be a use case where I say I can't use the SignalStore feature because with this approach, I can't be sure if it's a method or if it is something else. For example, as we know, a signal itself is also is also a function. Yeah, and then let's just do it. So I would say here I have a new file which is called withProfiler.ts. And I say export function with profiler. We know already the rules of the game. I have to say here I have an input, extends SignalStore feature result. So what comes in? I am already saying here this is going to be a SignalStore feature itself with an input. And now the nice thing is, because I'm adding only proxies to the methods and nothing else, I'm not returning or I'm not adding anything. So I would say here the empty feature result must be enough. Yeah, so we are not adding anything, at least from a type level. Of course, we add the proxies, but from a types perspective, nothing is going to change. And we use the usual structure where we say we have then here the clone of the store, and this is what we are returning. So from TypeScript's perspective, everything's already all right, because it says you said you're not changing something. And this is also what I see here, because the type that goes in is also the same type that goes out. So everything is in order. But I now need to access the methods. So I would say here, we have here our methods. This is what I want. And then I'm iterating over all these methods in a for loop, and I'm going to add a proxy to them. The methods will be completely replaced by the new methods which have the proxy. So I could then say here, these are the proxied methods. At the beginning, it's empty, and I can say that's as type of methods. So that's also clear that it's still the same type. The TypeScript's not confused. Then I have a const where I say we have our method name. We are going over reflect own keys. We are going over the methods. And I'm going to use here reflect own keys because own keys also contains the symbols, which could also be used for a key of a method. I say the method name is a key of type of methods, so that we can then also safely access it via an index. And then it's just going to proxy methods I say I want to add a new property, or I want to override it from TypeScript perspective. TypeScript says it's fine. That's a type safe access because name is actually key of those methods. And in the end, I then just call the add profiler proxy function where I say, look, from my methods, I want to access the name. This is the one where you should add your proxy on. And by the way, the name of that one is just the name. And of course, this could now also be a symbol. So it starts also a number. So let's just convert it to a string. That function is also happy. And then we are just adding our proxied methods one after the other. And in the end, when it comes to the store, we are saying, yeah, and our methods are now the proxied methods. It's the same methods from a types perspective you had before, and that's it. Yeah, then I would say worked well so far. Let's also give it a try. So I'm going back to my holidays page, holiday store, sorry. And here I say with profiler. So, and if you remember, or if you see here, in onInit, we immediately call set user. That is a method as we have defined it before. So we should see this in the log. And then depending if the store is loaded or not, the load method could also be executed. Looks good. Let me quickly restart it. Yeah, that looks pretty good. So we see here profiler, set user. We also see a profiler load. So both methods, let me make this a little bit larger. Both methods were executed. We have here a duration. We also have here the parameters. The return is also there. It works as expected. Yeah, so this could be a way where you have to let go of the benefits that the SignalStore feature provides you and do it on a low level. But again, before you really do it, think if you actually have to do it, because the SignalStore feature is always the better option, the easier, the more maintainable, and so on and so forth. One question that I hear very often is, how can we split up one single SignalStore into multiple files? Before you want to do this, there are some things that you maybe should do before. First of all, what we have already done here. So you try really to squeeze out certain generic extensions. So like with DevTools, with Favorite, with local storage. So you take them, put them into their own extension. If that doesn't work and your store is still too large, then the next approach would be that you maybe split up your store into multiple signal stores. And they could then collaborate with each other by using, for example, the events plugin. There is a video about this. Or you just go with plain dependency injection. So one signal store is injecting the other. That could also help. But if all of that does not help, then you can apply or use individual extensions to split it up into multiple files. And what I usually do then is that I say, okay, I always have something where I have my state and where I also have my extensions that I want to load into my SignalStore. And in this case, this is what I would call, that's the base. Yeah. So this first part here is always the base. And then this is now independent from the order. I then also have the logic, which is the with methods. And I also have then, of course, the with computed, which also gets its own specific SignalStore specific extension. There is also another common pattern. Very often you might also have one huge method which spans over, I don't know, 20, 30 lines of code. If you have this, then just take that method, extract the code, put it into a service and inject the service into your with methods. So you have then in your with methods a one-liner, which is just calling that Angular service, and that also already helps. But in our case, we really now want to say, okay, we have these three parts and I want to extract them to separate files. So how do we start? First of all, we would start with the base. So again, to me, the base, this is the way how I usually do it, is the state and the extensions. So I stay actually in the same directory where my store is located, because it's not meant to be now a general extension. And I would now say this is a with holidays store. So I really call it like the store itself. And I would say here base TS. And then it's the usual stuff. So I would then say this is with holidays store base. I'm using the SignalStore feature again. I'm not going to use the other one. Like I'm not going to write it without it. And then for the start, it's just a copy and paste. Yeah, for the base, it's always easy because there is nothing which the base depends on. That's also why I like to call it the base. So let's import everything. Let's check if it's working. The local storage comes from us, not from our toolkit, and we are done. Good. And now I go back and I say here, this is with holiday store base. As easy as that. Next are the methods. So I would then again copy the methods, would create a new file again, and would say with holidays store methods ts. Again, the same thing again, with holidays store methods, return SignalStore feature, and I'm copying the with methods in it. And before I'm adding all the missing imports, then we do now have certain constraints, because the methods, they need to run on that state itself. So this would now call, actually, at least in my opinion, as you remember, there are now two ways on how we can make this dependency between this extension and the actual SignalStore. We could use the withFeature function, where I from the SignalStore can provide something to the extension. But since those extensions are now specifically made for the holiday store only, we don't need to have the decoupling. They are not general extensions, they are specific ones for one particular use case, which is why I would go here with the input constraints that I've removed before. So I would actually go now with the type. Of course, I also need to I can now add all the imports. I think the type, it's coming from SignalStore, right? And now the question is, what do I define now? Usually the methods are based on the state. So we need to have now the type of the state. So what I would do is that I then usually create another file which is called the model.ts, and I'm using the model.ts to define the state of my holiday store, the interface of the state. So I would then say I have an interface holiday store state, and that one, I have to look it up, contains holidays array is loaded and the filter. So let me quickly copy that. Model. There we are. So I can then say here, this is a holiday array, but then also make it a little bit easier for me when I use it in my with state, because I don't have to come up with these TypeScript assertions. Quickly importing it, and then in my method, in my base, first of all, I could now say this is the holidays store state. So I can remove this. I can initialize an empty array as well. Why not? And I now go back to my holidays store methods, and I say here I have my state, which is coming from holiday store state. So far almost good. We see already the problems coming up. because the holiday store methods or the base doesn't just have my own state of the holidays, it also of course contains all the state that my extensions provide. And in this case, I'm missing the favorites because they are provided by withFavorites. So you could theoretically now say, okay, if the favorites IDs are missing, then let me quickly add it. So I would then say here we have our favorite IDs. This is also another array of number. That would fix it. Yeah, but usually this is not what I like to do. It doesn't feel like a very nice solution. What I would argue is that usually the provider of an extension, so withFavorites, should maybe also provide the state so that it can be reused then also from its consumers. So, and if I go into withFavorites, we see it is already there. So we have here the interface favorite state. So I can export it. That's a good start. Which means I can now go back into my holidays methods and I can say yes, and I also have here my favorite state. That works. But we are not, or those extensions are not just exposing state. They could also expose methods or props. It could also be there, and our methods might want to use them. So for example, I could say when I do the search and after I have patched my query or my filter, I want to go to the store and, for example, I want to sync to local storage, or however that method is called, which the base is actually introducing. And for obvious reasons, those methods are not available. So I would have to come up here again with methods and need to provide in here the methods, which means again, the same thing that I have done with favorites, that I would go into my local storage, and that one now would be responsible to define the methods that it is going to expose. So I would then again say, okay, we have here an interface, a local storage methods, and then I would then say here sync to storage, which in the end is void, load from storage. Did I call it storage? Yeah, both storage. Also like this, and then also here void. And if you do this, then after some time you will realize, yeah, maybe it's better if I have extensions which not just exposing methods or state, but maybe both, that it's better that I'm providing here the same structure that my input constraints require. So in the end, I could say here, well, state, methods, and props is something that I want to expose. So I would then say the local storage, I wouldn't even call it methods anymore. I would just call it local storage feature. And then I would put these into the methods. And if I would have state, or if I would have additional props, then I would add another property to that interface. And the same is also what I would then do in favorites. So in the favorites, of course, the state is needed internally here, but I can always say I want to create an interface favorites feature where I say, well, there is a state, and in that state, it's just a favorite state. So I'm going to reuse here the other interface. And then in my methods, going back again, it's now a little bit easier for me because I just need to come up here with these types. So I could then say, we have here our favorites feature. There we have it. And we also have our local storage feature. And I'm making this now on my own. This is then the holiday store state. Yeah, so something like this. Oh, what's wrong there? What's wrong there? Maybe not use a comma. And now that's a little bit better. And let's now say you're continuing to do this, like each feature contains its own kind of interface. Then after some time, you will ask yourself, why do I have to do this? Why do I always have to define the methods, the state explicitly if the same information exists already in the feature function itself? Because if you look here at with local storage, and we've seen this before, it's just a function which is returning an object literal of state, props, and methods. It's exactly the same type that I'm using for my input constraints. So the information is already there. I just have to make use of it. And here we need to apply conditional types. There's a small trick. It's a small type, more advanced TypeScript stuff, but we can automate that so that I don't have to write it all the time on my own. The way how I usually do it is that in my utils or somewhere else, I would then have a new type. So I would then say this is a SignalStore feature type TS. I'm going to export that name, SignalStore feature type. And that type wants to have now actually the type of this function. And if you remember what this function is that it says, I'm going to return you as SignalStore feature. No, not like this. SignalStore feature. And since this is not an existing type, I need to write it like this, because otherwise it's not going to work. And so I say I want to have this type. And the nice thing now is that I can now, if I look here at the SignalStore feature, then we see that it comes with the input and the output. If you remember, we have discussed this before. And what we are interested now in is the output, because the output type, the second type, defines methods, props, and state that the feature adds to the SignalStore. And with TypeScript, we can infer the type. The way how we do this is by applying now conditional types. So what I'm saying here is that I say I do have another feature. The same feature. Does it really extend the SignalStore feature? Of course it does, because we already have here the constraint feature. Yeah. But now I can say that I'm interested not really in the first part. So I would say here the input, it's not really for or out of interest for me. It's an empty feature result if that's enough. But the second type is something I want to infer. And I want to infer here the output. So what TypeScript now is doing, it says, okay, if the type that you provided me to the SignalStore type is of SignalStore feature, yes it is, then I can infer the second type, which is the output. And then I say, if that's true, which is hopefully always true, then I'm returning you the output type. And if not, then usually it's going to be never. So that's the way how it is. Again, this is more advanced TypeScript stuff, but I can infer here the actual type of my SignalStore feature. How do I use it? Very simply. I just go back and I say my local storage feature becomes now a type. And I just say I want to have a SignalStore feature type of with local storage. So, and we see this is not enough. Why not? Because the type of with local storage is not a SignalStore feature. It returns a SignalStore feature. So the return type of with local storage is actually the SignalStore feature. Sounds a little bit complicated, but in the end, I could then say here return type like this. And then it works. And if we now take a look at that local store feature, it says state props is empty, but methods does exactly have what you have typed in. So I don't have to repeat myself. It's not redundant coding that I need to provide here. It's just what we have defined in our function. In case you also want to get rid of the return type, because you have to type it in all the time. If you say I only want to provide type of with local storage, then we usually have to be a little bit more careful because we would have to say here that this feature extends a function which returns a SignalStore feature. And this function I also have to provide in here. And now the problem is that, of course, the with local storage is not just a name in a function with no parameters. It has 3 parameters. So I would have to provide here, I would have to catch all the arguments as well, where we usually can say we want to have here an any, which means we don't really care what it is. Then it just works for any amount of function. We see the error has gone away, and I can keep the type of with local storage. If you are not a friend of any, in the value scope in TypeScript, where we really write code, which is then compiled, and also is there in the runtime, we should never use an any, but here we are on the type level. There it's usually more acceptable. But if you say, nope, you don't want to have it here, you can't use an unknown, by the way. You have to use something which is maybe a surprise. It's going to be never. So you really have to see it. This is a never type. And if I now go back, we see the compilation still works. And if I would have said unknown, which is more, I would say, which is more likely to be the candidate, then we are failing here in terms of TypeScript. The point here is it kind of flips the side. We are here again on the type level. So what we were actually saying when we have an unknown is that we say you need to provide me with a function that accepts any kind of unknown, almost any type which is available. And then of course TypeScript says, yeah, but this is not the case, because the parameter here is clearly a string, 2 times a string, and then we have here a Boolean. So it's not an unknown. There are real types included here. And this is where this message is coming from. So we have to go to the other side, because of the opposite side of unknown is the never. And in some way you can also see it like, I don't really care what type the parameters are. I don't even want to look at them. If they're there, they're there, but I'm not interested in them. And this is then the way how it works. Yeah, so what I am going to do now is that I will apply the SignalStore feature type. Oh, there is a typo. The SignalStore feature type to all my extensions which I have already created. And of course, we also can provide it to withUser. Although we were not using here a SignalStore feature function, we have written it on our own. It doesn't change the fact that it's still a function which is returning here a SignalStore feature. I actually have written it, so why should that one also not work? So I would then say here we have a user feature type of SignalStore feature type of withUser. So what I can do now is that I can now go back to my methods. Where do we have them? Let me quickly close all that stuff. Methods, and now I can really use here all the different types. So just to be sure, whatever I have implemented, also the last updated feature, for example, which means if I would now have my local storage synchronization, then we see here the sync to storage is now also immediately available. But still, it's not optimal because I still have certain redundant information here. I don't want to write this myself all the time. So in that sense, I could say, well, this information here, this is actually coming from my base. So the base could now actually say, look, I have already provided you with the holiday store state. So in some way, I can also provide you with a type where we are including all the types of these features. That is one option, but we can now make use of the SignalStore feature type here as well. It's kind of a nested SignalStore feature, but it's still another SignalStore feature, what this function is returning. Which means I can say I have now holidays store base feature is SignalStore feature type of with holidays SignalStore base. And if I now take a look at the type, maybe I should also save it, then we will see it contains the state, all the state, also the state coming from my extensions like favorite IDs, but I also have the methods. So everything is already available there. And that of course makes it now much more easier if I go into my methods, because here I just have to say I have just one type. It's just the holidays store base feature. And everything is there. And we see the compilation also works. So that's now, I would say now we have reached a state where we say, yes, we are really able to split up our SignalStore to multiple files, and we also don't have to accept redundant or a lot of overhead code. And of course, the same what I'm doing here with methods, I also have to do with my computed. But in the same way, that's also very easy. So I would first of all remove here all my methods. I would replace them with holidays store methods, just call it. And then with my computed, I'm doing the same. So I say with holidays store computed, TS export function, with holidays store computed, return SignalStore feature. I'm providing here the type, the same type that we had already before. So usually in computeds, we don't use the methods. So it's safe here to say I only need to use the base feature. And then I come up with my computed, or actually can also copy it. It's faster. You know, like this. Put it here. Import everything what is necessary. Right, holiday space feature. Are we missing something? Where is the with computed? Don't see it. I think here. It was created here. So let's remove it. Yeah, and now the errors also go away and we are fine. So in my holiday store, I can now safely say with holidays store computed. Thank you very much. I keep the provided in root, of course, in my main SignalStore. The profiler, I would say that is a little special. That's why I also kept it here. And the with hooks, it's a certain SignalStore individual logic, which I also want to keep in my SignalStore. So that's the way how I usually try to structure it. In case you are saying you want to maybe do certain other things, for example, you want to separate the state from the extensions that you add, then of course you can also say you have a with holiday store state and with holiday store extensions as you want. The principle though, that is always the same. You use the SignalStore feature type and it will save you a lot of time. In case you say my store is so complicated that I can't do that, then there is also another approach. So what I mean with I can't do that is that you can't, or that you don't really want to come up with those types all the time. Here I'm wrong, but maybe for example here. So if you say, yeah, but I have not so many types and I don't want to apply them everywhere, then there is an alternative approach, where I have to say I would not go with that one in the first place. I would always try to do it as I've shown it here. But you can do something which I like to call like a builder pattern. Let me quickly show you what I mean. So we would still have our holiday store with builder, I just call it now, with builder, that we are able to separate the two from each other. And I'm going to copy the holiday store into my builder like this. And we would also start empty, I would say. So we keep the corpus with profiler and all these things. Of course, this is going to fail. And I would have the same base extension as well. But what I'm going to do now is that I will give it a number. So I would say this is now with holiday store base TS. I'm going to copy what I had before into the new one. Here we are. Okay, SignalStore feature. Something's wrong. Yeah, again, the wrong local storage. Please use ours. Actually, it's both from NgRx. Good. And so that's the holiday store base. And then I would create another one, the methods, with holiday store methods TS. Yeah, I would again copy the methods as I've done it before into that, also removing, re-importing the imports. Do we have an all missing? Yes, good, we have it. And now, because I told you before, I don't want to provide here the type. I don't want to do this with input constraints for whatever reasons. I would add here, I would call here with holiday store base. So what I'm doing here is that I'm saying I am not just creating here the methods, but I'm creating the methods, and before I do this, I'm adding the state here as well. So the name might be a little bit misleading. I'm still unsure about how we want to call these features or these functions, but it's kind of incrementally adding one feature to another one. So it's not like it is flat as it was before, where then the SignalStore would just call all three different ones. But the second one adds the first one. The third one adds the second one, which means it also includes the first one. The fourth one does it also for the other three of it before, and so on and so forth. Which means we don't have to deal with those input types anymore. And this could be really helpful if those types are getting too complicated. So for the with computed, I would now also call it with holiday store computed. And I think you see now why I'm using here a number as a prefix, because that's the order of how the features are calling each other. So copy this, put it here. Don't need the type here. And instead, I'm saying I need to import the holiday store methods and just the methods. I don't need to import the state anymore, again, because the methods do already contain the state. And you see, type is gone, but it's still type safe because, again, the computed is now containing everything what the others have already defined before. And then when it comes to my holiday store, I now, and this is something where I have to say, this is why I don't like this pattern that much, because I'm now actually importing the holiday store computed like this. You see now everything is again here, but this store computed, that name, that is the main problem for me. The name can be misleading. So if you want, you can actually call the last, if this is the final one, or how I like to call it, like kind of giving it here an alias, where I say this is with holiday store body or something like this. If you know a better name, please let me know. I would be very interested. It would be very interesting what you can come up with. But yeah, this is what I have at the moment. Yeah, so let's do the recap. We have seen that the first approach would be that we are using here these very specific features, which are only designed for the holidays store itself. There we have to make use of all the different input constraints, but in our case, it's just always the store base feature that we need to include in computed init methods. And a lifesaver in our case was the SignalStore feature type, where we can provide whatever feature we have, just the type of the function, and it will generate a new type that contains the state, the methods, and the props. This is what I would do. And if you say, no, this is something you don't like, then you can also come up with the builder pattern, which means that one feature is loading the previous feature. We do this until the last feature, and the last feature is then added finally to the SignalStore itself. If you have liked the TypeScript part here of the SignalStore feature type, then I think you will also love the next chapter, which will be about dynamic SignalStore features. Let's now move on to the dynamic SignalStore features, where we have dynamic properties, state, or also methods. If you look at the holidays array here, then you're probably aware of the withEntities extension of the SignalStore, which we should always use if we have a list of entities that we want to manage. So we want to create a new entity, we want to maybe remove someone, or we also maybe just want to update a particular entity. So in this case, the way how it would work is that I would say withEntities, provide here the type of it, save it, and what I will get then is that I'm getting an entity map in the state together with an IDs. Entity map seems to be a dictionary, so to say, and IDs is a simple array. And we are also getting in the properties the entities. So that's, in this case, the list of the entities is a computed. Why? Because in the state we are using a data structure, a map, which supports a very performant lookup. This is the way how we use withEntities, so that we don't have to care about these things. But you could now say, yes, I have the need for a very similar feature, but it should be a little bit different, because I don't want that whatever type I define here, that the property is always called entities. I want to be able to define the name of it. And withEntities doesn't support this. But we could say, because we can also write our own extensions, let's just call it withCollection, maybe it's similar. Then I say, look, I also want to provide here the type, and I want to say here that this is _holidays. So I want to have just a list. We're not making it too complicated as it is withEntities, but in the state we just keep it as a list. But I want that in my state that list is now available. Of course, I also have to remove it then here from this type, so that we're not running into problems. Good. And of course, for obvious reasons, now this property is missing. So how do we do that? Yeah, let's create the type. Let's create the extension. So here, I would say withCollection, TS. I'm going to export the function withCollection. And as I said, I would say you give me the name of the property that I should use. We have here a SignalStore feature. I'm going to use here with state, And I will just say, I use the name that you have provided me with a key, and this is going then to be whatever type you have provided me. For the type, we need to use generics. So I would then say here, this is collection. And then I would say here that in the state, I have the collection observable, like this. Not like this, sorry, as collection. So does it work? Let's go back. Let's check out the state that we have. With collection should be imported. No. And now we see that this is our holidays array. So it has been added to the state, but not the way how we intended it, namely that it has the holidays property. In this case, TypeScript says it's just something which is a string, and this is where you find your holidays. That doesn't help us. So we have to do something else. We have to maybe be more clearer about the type itself. What can we do? Well, we can narrow down the type in this case. So I say it is a string, yes, and it should say a string, but it is a very specific value of a string. So it's a subset, it's just actually one value. And I can call that with a second type now, where I say I have a very specific type for the name. It is just name. And that is also important, that name is now extends from string. So I have now the type for a very specific key in this case. Does it help? No, not really. We still have our kind of unknown property. What would help now is that we now maybe have to dig a little bit deeper into the SignalStore feature itself. Because if we look at it, then you see here that this is actually where the problem is coming from. The SignalStore feature in its signature says that I'm going to return name, which I don't know what it is, except that it is a string. And that's the root cause. That is why it's not actually working. You could now write the type on your own. So I could say, okay, we have here a SignalStore feature and then provide input output. That could maybe work, but I'm someone where I say I don't want to provide now the type for the whole SignalStore feature, but for the whole with collection, because it could also happen that we don't have just state, that we also have methods and computeds, then I would have to provide all of that as well. And I want to have TypeScript to infer the type as much as it can. So TypeScript in this case just says, yeah, I know the type because I see how what kind of types you're using, so I'm able to infer the right type. Theoretically speaking, if I look at SignalStore feature, as you have already seen before, I could also provide here the type, which I don't want to do. With state, maybe that I provide here the type. I mean, this is something we have already done, but I can even go more deeper because I can provide the type at the smallest level, which is actually right here at this object literal. I can say that this value, the TypeScript infers correctly, but with a type which is too wide, we want to narrow it down. And I want to say that, look, this, I am going to help you. So I'm talking to the TypeScript compiler. This is actually a record where you have one type as a key, which is that name. And that name and that record has then the collection array as the value, which means I can remove the collection right here, can leave it as it is like this. No, let's not go down that path. Let's just keep it here with as collection. It's then a little bit redundant, but I don't really want to use the unknown if I don't have to. So I'm able here to sacrifice a little bit more code than necessary. So in this case, we have helped TypeScript a little bit. TypeScript still tries to verify it. So if this would actually not match, it will already say, as you've seen before, no, this doesn't work. But in this case, TypeScript is happy. And if we go back, then we would see here, is there something missing? Yo, there is something missing that we also need to provide here the type, of course. So I also have to say here holidays a second time. And if I now look at the base feature, it says there is now an underscore holidays property available, which is good, but it's not optimal yet. Because the problem is obviously the redundancy that I have right here. So I don't want to write underscore holidays twice. Why do I actually do that? It's not the same thing, to be honest. So from a TypeScript perspective, we have to be different. We have to differentiate it here, because this underscore holidays is not a value. That is a type. That is a type which is just which extends from string as I defined it, and that type has just one value, which is underscore holidays, which is then here where we find the value of that type. Sounds a little bit confusing, but that's the way how it is. And it's also type safe. Because if I would add here, if I remove the underscore, then TypeScript would rightly tell me, no, this is not the right value for the underscore holidays type. So I have to write it like this. But I'm not happy. I only want to write this once. The problem is, the question maybe is, why do I even have to provide the second type here? That's just the way how TypeScript works. If you have type in your types here, they don't come with default values. Let me use the nice one. And your types don't come with default values, and your caller has to provide one type explicitly, then they have also to provide the other types. And since I have to provide here the collection, I also have to provide the type of the name as well. Yeah. So I say here, I have to provide here holiday, and that's why the second type is also necessary. Well, in order to fix this, we can move that type as a value as a second parameter. So what I want to do is that I want to say, look, I want to have here holiday, which means if I have here a second parameter, then I can add here the second parameter. I can actually call it type, and I say this one now is the collection. And now TypeScript can infer the types by just checking the properties. Because TypeScript says, I see what name, I see what type the name has. I also see what type the type property has. And that's why you don't have to provide these things for me explicitly. I am inferring them. But we see it's not working. And the problem is that holiday, it's not imported. That this holiday here is a type. So I'm actually providing a TypeScript type as a parameter to a function, which means when this whole thing gets compiled, this holiday, which we see right here, does not exist anymore. So we would actually provide an undefined or pass an undefined, and that's not good. And there is a nice trick. So I can, for example, say, well, I just provide something, and I just tell TypeScript this is a as holiday. So I'm providing here some value, that's the value, and then I say TypeScript, this is a holiday type, which means TypeScript could now, maybe not infer, but it takes the type that we have provided here. And then we see it works. So if I go here, then we see it says underscore holidays. And it seems that we are almost done. Maybe just to save it. There is a problem in another file. Let me quickly open that one. That one is gone. Okay. This is the base builder from the former chapter that we actually, that's an error coming from somewhere else. Okay, now it's fine. Let's go back. Holiday store, here we are. No, here we are. Yeah, so we have now here provided the value as a type. And if you don't like that, if you say this looks like a very hackish approach, then you can always hide it behind a function, which is actually what we have already been doing all the time. If you remember, there is a type function from the SignalStore where I just have to say holiday, call it, and in the end, that function is exactly doing what I just did. So if I go back then here, then we see it's again underscore holidays. All right, and since it is that much fun to work with TypeScript types, we will extend our with collection now, and we are going to add a new method to it, which should also have the name set holidays, and we also want to make it conditional so that I, as a user of with collection, I can define if that method should be added or not, and it should be full type safe. But let's start first with the method with its name that it has set holidays. So, for obvious reasons, I would say here with methods, I'm getting my store. And then I could say here set holidays. So just write it down as I would know that it's called set holidays. Let's start simple. We would then say here, we have our holidays. That's the collection type. And then I say patch state. Now it becomes again interesting because now I have to go to the state, I have to go to the name, and I have to provide here the holidays. And in this case, our TypeScript again starts to complain. Maybe let's also call it collection. It's not that it's going to change anything, but it's more like a generic name. The problem is unveiled here. It says, well, I don't know what this name collection is all about. I only see that you have a record name on collection array. So in this case, we would have to help TypeScript again. So I would then say here, this is a record of name and collection array. So TypeScript again starts to complain and says, no, because you need to provide me a partial. The record name and the collection array means that you're always providing the full state, but it should be a partial, please. Good. I'll say it's going to be a partial. If you're happier now, add it like this. Compilation error goes away. Good. I can go back to my SignalStore feature, check out the type. And here it says set holidays. Wonderful. Now I want to make this also variable. So this one should now take on the name of that name. How do we do that? Well, I could say I want to add here a set, and that set should then have the name as like with a string concatenation. And what I also want to do is that I want to capitalize the name. Capitalize, hard word to write. So we have here a function where I say capitalize, it's a value with of type string, and we are going to return the value, first element plus value slice 1. I hope that this works, that this is the correct term. And well, then hopefully this one now depends or changes the value depending on what this name value here is. Let's check it out. We go back, we go to holiday space feature. I'm going to scroll down. And we have the same problem that we had already before with the state. It now says again, I only see a string. I am sorry, but you have a string which would actually do what you want. It would be a function that returns void, but it doesn't but it doesn't have the name set holidays. Back to our types. So in this case, I can, of course, if I want, I can again start to do here, don't even have to look it up, like the type assertion. But in this case, because it might become a little bit larger, I want to extract this type into an own type. Which means I would create here a new type, which I call these are the collection methods. And now I'm defining what with methods is going to return. That collection methods, of course, needs to know the type of the collection, because that's going to be the parameter. So I mean this one here. And of course, it also needs to know the name, because this is what we're using here. And that one will define the name of the actual function. So how do we do this? Well, we have the same kind of types again. So I want to say here, this is a collection. We then also have our name, which extends from string. And then it's rather easy, because I can say, well, it's just another record where we almost have the collection as a key, but this time it's again part of a template literal. So I would say here, there is a set, and then I can also use for types this kind of string interpolation that I can also use for normal strings. And in this case, I can say I want to set the name. And the rest, of course, is then the collection. And since the name needs to be capitalized, there is also a TypeScript utility function, which can now also do this, which is called capitalize. So it takes again the first character and does an uppercase. And with these new collection methods, I now go to my with methods and I'm going to add it right here. Here. So I would say, look, these are now my collection methods. Here you have the collection type. Here you have the name type. Also need to close it. And let's hope that this works. Doesn't work. Name is not assignable. Collection is not assignable to type function, which I think is true, because we actually said here that this is not a record where the value is a collection, but we said that the collection is a parameter. The collection array is actually a parameter, which returns a void. And now TypeScript has no objections anymore. It compiles because it says, yes, the implementation kind of matches the shape of your collection methods types. So I'm going to allow it, which is good. And if we now go back and check it out here in that type, then we see that it says set underscore holidays, which is not what I wanted, because I actually wanted to have set holidays with the H capitalized, but not the underscore. Logically speaking, it's correct, because we are providing here an underscore holidays, and that one capitalized stays an underscore, and of course the second one does not. I leave it up to you to fix it. That's your homework, or you can also look it up then in the exercise or in the solution branch. And we will continue with the conditional part, because maybe I don't want to have set holidays always in my SignalStore. I want to be able to configure it. And how do I want to do this? Well, I just say, for example, here, false. I don't want that method is added. Let's check it out how this could work. We, for obvious reasons, would have now a third parameter, where I would say add setter, which is a Boolean. I go to my implementation, of course, where I would then say if add setter, if that one is false, then I'm just going to return an empty object literal, which doesn't contain any methods. So far, so good. So when I say false, this method does not exist. But if I now go back and we have here false, and I go to my feature, then it says it's gone. Wonderful. But we can also try it out the other way around. I could, for example, say it's true. And if I now go back, then we see it's still not there. The reason is that TypeScript sees here that we are returning two different types. First, we could return here the empty object, and second, we can return it the collection methods. But in the end, what we actually have to tell TypeScript that always collection methods are returned. So I could, or I actually need to put it right here. And if I do this now, and I go back to my type, then we see that it now says again, set_holidays is there. But if I say now false, it's still there. And this is what I meant before in the value space. So here, this is the code. Here, I have already implemented it correctly. So during runtime, the method will not be available if I provide a false. But in the type system, this logic is not reflected because here we have no conditions. We are saying we are always returning the setter method. And that's why we have to also integrate it here a second time, which means this type needs to know the value or the type of add setter. How do we do this? It's not the value, it's really the type that it needs to know. Well, we apply the same approach that we had before, where we said name could be a string, but we are focusing on the specific string value which has been provided on the call side. And this is why we say here we have another add setter, where we say that one is going to extend a boolean. And instead of providing here a boolean, we are saying you give me add setter. So TypeScript can now read from the value that we are providing. It will infer the type, which will be either here false or true. And then we can use this here when we are creating the methods, the method type. So I say here, add setter extends boolean as well. And then I come up with a simple condition where I say if add setter extends true, and you know this conditional type from our SignalStore feature type before, then I want you to return a record. And if it's not true, then it should just be empty. I also have to add then here my add setter tab here, and then also here. Yeah, compilation works. And if I now go back, it says here false. I go to my type, that the methods are missing the set holidays. And if I now say here true, and I go now again back to the type, then the set holidays is right here. So we have now a conditional type where the user can really define if it's there or if it's not there. If you're interested in more of these things, there is also a live stream which I did with Michael Small, where we actually re-implemented the complete CRUD features. But for now, one method is already enough. All right, and now let's come to the last topic, which are non-polluting features. That's a term that I've made up, not an official term, but let me quickly explain what this is all about. So we know that with each feature that we generate, that each feature will add probably methods, state, computates, or something else, but it will always add certain members to the SignalStore. And it could not be the case if I open here, for example, our withFavorites, that someone is adding here a state property which is called IDs, which would be a very bad idea. Because IDs is definitely a property term, it's a term for a property, which maybe also other SignalStore features might require, or maybe even the consuming SignalStore wants to have in its state IDs. But here I'm reserving it, and in this case I'm kind of polluting the SignalStore which is using me with my own members. The solution, of course, would be that we find a way how we can add things to a state where we are not polluting anything, but where we then also allow to read, but also write to that state. But in a way, again, where we are not kind of coming up with additional methods or properties in the SignalStore. We have already seen in withFavorites, at least for the methods, how that could look like, at least for the very simple methods, where we say, look, we have here, for example, add favorite, remove favorite. In this case, these are functions which in the end will just manipulate the state and nothing else. But the way how they do it is that, again, they just have here the state and they're saying, look, you can implement whatever method you want, however you want to call it. We are not interfering. The add favorite and remove favorite are updater functions. You just put it into the patch state and that's it. We are not polluting the state with it. This is one thing. The other thing, of course, is then that we need to find a way how we can apply these principles to the state, but also to the computeds. And here's a way on how we can do it. Let's start first with the state. So I need to find something where I can be sure that only I can use that property name and that it's unique and no one else can reuse it again. Or that no one else can actually come into the situation that by coincidentally using it. And this is something where symbols are actually a good fit. So if I say here I have a symbol which is favorite IDs, then this means that no one from the outside, or maybe no one who knows, for example, the name here of that string, can replicate the same object reference again. Because if I say here symbol, for example, A, and I do here an equals to a symbol also with A, then you know what JavaScript is saying. These two things, they are not the same. They are different object references. So I have a unique name, symbol, that I can also use as a property name. So instead of saying here IDs, which was a bad name, I just use favorite IDs and I'm storing it then here in a state. If I want, I can then also hide it from the outside, so no one can actually direct access this one, which is something which is also good. The only thing that I need to do is that I just don't export it. So no one now can actually directly access the favorite IDs, which means I'm now responsible to provide something. And that means that we are providing here a function which is called getFavoriteIDs. That function needs to have access to the store. So it gets the current store, the SignalStore, which is using withFavorites. And I don't need to know what kind of store that actually is. For me, the important thing is that that store contains a property of that symbol favorite IDs. So that's a TypeScript thing where I can say it's just a subtype that I'm requiring here, kind of like a dependency to the store. And as long as that one is a signal of type number array, I am happy. And then I can return store favorite IDs. Like this. We also have then here the interface. Maybe I can also remove it. I would then say, okay, these are the favorite IDs. This is now actually the state, which means I could now also update here my add favorite and my remove favorite. So I would then say here, this is favorite IDs, and state does have access to the favorite IDs, like this. What is the problem there? Good. And then we are doing here the same thing again. Favorite IDs like this. Yeah. Now we are providing reading, but also writing functions. And if you say add and remove is not enough, I need to provide a full setter. Yeah, that's also not a problem. Then we'll just say here export function, set favorite, where I say give me just your favorite IDs, whatever you have. And then I am returning just an object with favorite IDs, and there you go. Now everyone from the outside has also access, has also the possibility just to override whatever is already in the favorite IDs. Let's go back to the base. So we are now again in the consumer perspective. If we take here a look, then we see that this holiday store base feature is aware. So TypeScript is aware that favorite IDs does exist, but because it's a symbol, it's unique. So no one, even if someone would create another symbol with the same term, could kind of override it. And in this case, we also decided to not export the favorite ID symbol, which means no one from the outside can directly access it. It always has to go via our getter and setter functions. And this is what we see right here, because withFeature is already trying to access it, and therefore we have to override it a little bit. So we have to add here certain braces. And as a matter of fact, I think this feature had a bug all the time, maybe already from the first unit on, because I'm not calling here these signals, which means whatever last update it is doing, that one's not going to be reactive. But yeah, we are saying we want to have here the store. I am going to add then of course here the holidays, and I would say store holidays, call it. Would do the same with my filter, would also call it favorite IDs. I can call it like this. And of course now there are no favorite IDs available, and that's why I say here get favorite IDs. Here you have the store. The get favorite IDs returns me a signal of type number, and that's why I also have to call it here. Otherwise it won't work like this. Good. Remove braces. So this is it for the base stuff. I think we then also have something in the other functions. So if we, for example, if we go here with isFavorite, we have the same issue where I say here get favorite IDs, provide here the state, in this case, also call it. And in our methods, do we also have a problem somewhere? No, not really, because my methods have been using add favorite, remove favorite all the time. So they never, so this is an implementation detail. In this case, it's as long as add and remove favorite implement the right access to it, everything just works. So again, from my SignalStore's perspective, I'm not polluting my state with favorites. It doesn't add anything which I might also want to use. Like if I now say I want to come up with a state that is called favorite IDs, I can do that. But, and this is maybe also an important thing, I as a consumer have now the chance to decide what I want to do. If I want to expose setter methods, and if I want to expose a property maybe called favorite IDs to the component, or just internally with an underscore. It's not really up to me to decide. For example, if I want to have it in the same structure as it was before, I could very easily say here I have a computed. The computed, of course, has then access to the state. And then I would say, look, before we had an underscore favorite IDs, so it was hidden. And then I can say here again, get favorite IDs. I just call the state. And then it's part of my store, which means I can also say here store favorite IDs, call it here as well. So it's kind of again what we had before, but I made the decision. I, as a SignalStore, as the holiday store, made the decision to add the property favorite IDs, and it was not enforced upon me by the withFavorites. That's the point here. And just to be sure, because I think that question will come up, that you say, that's nice, but I have a little bit more logic in my features than just patching the state somewhere. Yeah, then it's also not a problem. Then just create services, which are then, of course, injectable. And then you have the same thing again. Your signal store doesn't have enforced methods, but it can decide when and how often it wants to inject the service. And that service could then provide add favorite or remove favorite methods. Yeah. So what I mean is that you would then say here you have an injectable. That one is provided in root, export class, favorite, service or favorite helper, signal store helper, however you want to call it. And then you have here the add favorite. And in the end, it's the same thing that I have done already here, where I say it again gets the state, or returns in this case here the state, or it wants to have the store. Maybe we can even do it like this. So it says here, you give me the store, and the store should in this case, because now it's about calling patch state in the favorite service itself. So you would have to say here, the store has a writable state source, which contains the favorite IDs, which is of type number array. And so this is the way how you can define if you have a certain state in it. And then you can say here, I have a patch state where I'm using my store and doing something like this. Of course, the ID should also be provided here in the form of number. Good. Favorite IDs. Oh, from my store, I want to have the actual favorite IDs. Nice. Maybe I can also do it like this. Then I say here state. Then I can access the state from here. Also add the right parentheses. So. And this is also a way on how to do it. Has no call signatures, of course not. Yeah. It took a little bit longer, but this now I can also do the patch state, and I can do whatever before logic, but also whatever after logic I want. And in my signal store, in my holiday store in this case, where we have the methods, I can always then say, look, in this case, I want to inject not just the holiday client, but I also want to inject the favorites service. Like this. And then here, I just call it like this. So favorite service, add favorite, store and ID, and that will then do the job. So that was everything I can tell you about the extensions in the Signal Store. And I want to again highlight that we as NgRx team also provide the official workshop. At the time of this recording, the workshop lasts 3 days, where the first day is more about the global store, and the second and the third one is about the Signal Store. The trainers, as I said, are members of the NgRx team, so you will find Alex Okrushko, Marko Stanimirovic, and myself. So it would be great to see you there. And about the content of this video, if you have any questions or comments, then please just let me know. And as always, of course, I would be happy if you like this video, if you subscribe to my channel, also if you share this video with your colleagues, would also help. And well, thanks for watching and see you in the next video. Goodbye.